Good afternoon, everyone, and welcome to this week's learning webinar. My name is Chantal, and I'm going to be your host today as we look at framing. We'll look at framing the walls, and the floors, and ceilings, and the roof, so you understand all different aspects of framing in the software. Following the presentation, I'm going to open up the chat panel, where you can type in any questions that you might have about framing, and we'll be able to answer those live. So don't hesitate at any time during the presentation to type in your questions. And then once I'm finished the formal part of the presentation, I'll be able to look at your individual questions. So let's get started on discussing framing. And the first thing I want to mention about framing is that it is available in our Building Essentials and Construction Suite software. So if you're using Pro Architect currently, you won't have all of the functionality that we will be showing today, but at least you'll be able to see what's available if you upgraded to Building Essentials or Construction Suite. So I just want everyone to have a clear understanding that framing really is available in Building Essentials and Construction Suite, and not all the features that you're going to see here in our Pro Architect software. So the first thing that I want to discuss with our framing is taking a look at the walls and how the walls are framed and how they get their information. So I'm just going to select one of the walls that I've already drawn in this model by left-clicking to select it. And then I'm going to right-click to take a look at the properties of this particular wall. When I'm looking at the properties of this wall, you can see that it's been set to framed. And if it's set to framed, then that wall will display framing when we go into a framing mode, and it will count the framing that's associated to this particular wall. If it's set to anything but framed, it will not frame. So if you have a wall that's set to general, you'll notice down at the bottom of this dialog box where I'm moving my cursor, the framing member grays out. That means there'll be no framing associated to that particular type of wall. But when it's set to framed, you'll notice that that now becomes an active point. So now I can pick the framing member that I want to associate with this particular wall. With the framing member that is associated to this wall, if I pick on framing member, it'll bring me into the catalog to look at all the various member sizes that we have available. Each one of these member sizes, like our 2x6, if I double click on it, it'll bring up its properties. So I can see the size of the 2x6. But more importantly, I can look at this Purchased Items tab. And this Purchased Items tab gives the length of each piece of this framing material that I'm going to use. So when I go to put in my studs, this is where it's going to look to see what piece of lumber it should use for that stud. And when I put in top plates and bottom plates and blocking in the wall, it's going to look at this Purchased Items tab to see all of the available lengths of lumber and which ones it wants to use. So you can see in this list that there is a pre-cut stud length there, and there is a rule, and I'm just going to draw a line there for the stud to say only use that length of lumber when its type is set to stud. And if I go to the 2x6x8, I can use it for anything but blocking and plate material. So each length of lumber that's in this list can have rules set to it, so where you want to use it. So not only am I telling it that I'm using a 2x6, but I'm also telling it particularly which lengths to use for the certain framing pieces of it. So in the parameters of a wall, the thing to be careful on is you set it to framed, so it knows to frame that wall, and you pick a member that you want to frame it with. So this particular wall is a 2x6 construction with clay brick. So the member associated to it is the 2x6 we selected. I'm just going to click OK there. So now it knows to use a 2x6 when I'm framing this wall. How it knows to use it, the stud spacing, how many top plates, is there blocking, all of that information is found under Settings, Building Locations. When you go to insert a wall, it always looks at this building location dialog box in the background as you're drawing the walls. And in here it obtains all of the information that it needs pertaining to the height of the wall, how far it's sitting off of grade, and this very last column of information, the framing options. So the framing options for the ground floor walls I'm going to pick on this little button right here to pull them up. While I was drawing that 2x6 clay brick wall, it looked here to say when I'm infilling that wall with framing, do so at 16 inches on center with a double top plate. If I double click on that option, it brings me deeper into the catalog so I can look at all different infills that are available. So if I wanted to frame that wall differently, I could do so. So if I wanted to add in a double top plate and a pressure treated bottom plate, I could choose this option. Or perhaps I wanted it to be 16 inches on center, top plate, bottom plate with blocking in the middle. You can scroll through all of the available options that are here, and you can see that there'll be pole barn options, there'll be steel stud options, there's even some log wall options in here. But as you're going through and looking at all of these different options, if you don't find the framing option on how you want to frame that wall here, you can right-click in this dialog box. When you right-click in this dialog box, it gives you the opportunity to add in a brand new configuration, edit one of the ones that are there that are close to what you want, or delete out all of the ones you know you would never use to simplify the choices that are here. I'm going to click on Add a Wall Infill Configuration. And when I do that, it is going to base the new configuration on the item that I was highlighted on. So it's going to get all of its bases from that 16 inches on center double top plate. And you can see it gave it the same name, but a -1. So I'm just going to erase all of that out and call it New Infill for our class today, if I can spell. There we go. So in the infill configuration, on the left-hand side are all of the different parameters that you can set. So here's the infill properties that I'm highlighted on, and in the middle, we can see all of the various settings. The last little window here is a preview, so you can see it as you change it, how it's going to look. So right now, the stud spacing is 16 inches, but that could be absolutely anything that you wanted. So I could set that to 36 inches, and you can see they would space themselves apart. The next setting down is called interference, and that happens when two walls are going to meet up with each other, say a T intersection. I'm setting my studs 36 inches apart, and where I have a T intersection, a wall meeting in with this other wall, there happens to be a stud there based on my 36 inches spacing. So what do I do with that stud that's going to interfere with this other wall that's coming in and its corner configuration? Do I move it to the next nearest location, or do I remove it and just delete it altogether? So you've got that option depending on how you'd actually frame it. So if that spacing hit on a corner, would you just move it beside it, or would you just get rid of it? You can make that choice. Cut opening bottom plate. So this means if I was to put in a door in this wall, do I want to cut the bottom plate, or do I want to leave it running through the opening? Two reasons you might want to leave it running through the opening. A, if you're a manufactured housing and you're shipping this panel out, you probably want to keep that bottom plate in place so it's a sturdier in your transportation. The next reason that you might want to run it through an opening is think of a waste factor. When we're calculating the quantity of the plate material and it's cut there, it's going to give you the two shorter pieces. But if you want to add that back in for waste, you could leave that running through, and that would give you extra waste factor. Projections into the plates. So this is saying with the studs, do I want to project them up into the top plates and the bottom plates? Think of steel framing and sending the steel studs up into the bottom track and the lower track. You could take advantage of that. So this is just projecting those studs up higher into the plates or lower into that bottom plate if you need to. And the start studs and the end studs. So when we come to the end of a wall, do I want to erase the very first stud and the last stud, or do I want them in there? So you can remove them. So you can be very particular on how it's placing the framing and the things that you can remove. On the left-hand side, we also have bottom plate. What member am I selecting? You'll see here it says wall properties. Frame the bottom plate with the member that was selected with our wall properties. So when we think back to that wall that I selected, that 2x6 clay brick wall, it had a 2x6 member set to it. So it's going to use that same member that I set in those wall properties to frame the walls. It's going to be tagged as plate material, and it's going to be shipped out with all of our wall framing items. The studs here on the list on the left are also going to be using the same member that we used in the wall properties. So what I selected with that 2x6 clay brick veneer wall is also going to select here to frame it with, that 2x6 member. You can rotate it, so if you wanted it to be 90 degrees for whatever reason, you can rotate the studs and they will rotate in the wall. So if you wanted them on the flat for whatever reason, you can do that. You also give them a quantity, usage, and phase for material report usages. And then how you're anchoring them to the wall. So as I'm putting in these studs, how am I positioning it along the wall? I'm positioning them center line to the top plates that are already there. I could offset them a distance if I wanted to as well, so I could shift them out one way or the other. And as far as position front to back, I'm going midpoint to midpoint along the bottom plate. And again, I could offset them a distance. Then we have blocking. Do I want any blocking along this wall? Once I've got it selected, I could hit New here, and you can see a piece of blocking gets set in there. From there, I can say, well, its initial offset is going to be 2 feet from the bottom. And here spacing, I could say, is 2 feet. So every 2 feet, there's going to be framing. And if I set the rotation to 90 degrees, then I've got it on the flat. So you've got some ladder framing going on. So if you needed some kind of backing, you could do that with your new infill and how you're setting those up. And again, it will have the same positioning options, positioning front to back. If I needed to move that out or move that back, I can do so, so it's going to be framed properly. And again, it's using that same member from the wall properties. Next, we have our top plate. Same options available. Use the member that we specified in our wall to frame for the top plate, label it as a plate, and ship it out with all the wall framing material. And the same for our very top plate. Sometimes you'll want to change and deviate from using the same member that you used and specified in the wall properties. Most of the time you'll do that, but think of your bottom plate, which I'm highlighted on right now. If I wanted everything to be framed with a 2x6, but this wall was going to be maybe in a basement location where I needed that bottom plate to be a pressure-treated bottom plate, then I wouldn't be able to use the wall properties member. So I would select here and say, I want to go to the member library. And when I'm in the member library, then I can choose my exterior grade lumber, choose my 2x6 treated board, and click OK. And now that's going to be my bottom plate. So you can frame it always with what's specified in the wall, which is the preferred method. But when you have that time when you need to switch it to something else, like a pressure-treated member, you can very specifically choose that one member, that bottom plate, to be the pressure-treated member. The reason we like to point it back to using the member that's specified in the wall is because in your model, you might have a mix of 2x6 walls, 2x4 walls. Maybe you have some pole framing that's using 4x4s. It's going to look at that wall and frame it with whatever you've chosen as the member for that wall. So you want to make sure that you're looking at that wall to use the right member. It's only in those specific places, like a bottom plate where you need a specific member, that you would use the member library instead of the wall properties. Okay, so I'm just going to click OK here, and that adds in this new infill to my wall infill library. It'll be there forever unless I delete it out, so I can use it on future projects as well. So going through here, you can select whatever infill that you want to use. Okay, I'm going to click OK there. Also in the framing options, you'll see span tables. There's a load-bearing and a non-load-bearing span table. These are used for openings in the wall. So if I punch in a door or a window, it's going to look to the span tables to see how I frame around those openings. Walls in our catalog can be set to load bearing or non-load bearing. And depending on that setting, that's when they're going to look here to see which table it should use. So I'm going to look at the load bearing span table as our example. The non-load bearing span table will have the exact same setup, but gives you the ability to set different members here. So here in our wall span table, I'm going to double click on this general 2-ply span table, just to show you different options. So if I was to choose this span table as the one I wanted for my ground floor load-bearing walls, it would say that any opening up to 3 feet will be framed with a 2-ply 2x4 header. And we get the little display on the right here of what that's going to look like. And there's a drop down if I wanted to choose any different header size there. Any opening that's above 3 feet but less than 6 feet is going to use a 2-ply 2x6 header. Any opening that's above 6 feet but less than 10 feet will use our 2-ply 2x8 header. And you can come through and change any of these, change the spans if you want to, change the members that are associated to them, add new spans. So if I wanted to add a span that's 18 feet and tell it that I'm going to be using an 11 7/8 PSL header, it would frame it in that way. You'll notice to the right of that selection there's a little button that appears. That gives you the opportunity if you want to go in and create a new header style that you can. So if I pick on that button, it takes me into the library where it's showing all of those header styles, and I can right-click and create a new one if I want to. Much the same as I did when I was looking at all the settings for the infill. The dialog box for the head sill jamb, you'll see, is very similar. The members are listed on the left. Their individual parameters are in the middle, and you get a preview to the right. So I can see that my king studs, my jack studs, my header, my sill material, cripples above, cripples below, and an additional king on either side of the opening is added there as well. So I have double king studs on both sides of the opening and a single jack and one single header. That's my PSL. Okay, and again, you can see they're the same type of parameters that we had for the infill. So you can create your own head sill jamb configurations or choose one of the ones that we've already set up for you. So I'm going to cancel out of here. That's the span tables. So you can point it to one span table for your load bearing and one for your non-load bearing, depending on how you want to frame out those openings. When we're looking at intersections, I'm going to look at those specifically out in the model to illustrate them a little bit more. But this is where you can choose a configuration, and this is more like a table of different corner configurations. And I'll, again, illustrate them better out in the model than here in this dialog box. The last framing option that you have here is the framing roll. And this means that when I'm going to start laying out studs 16 inches on center, where am I going to start them from? Well, right now it says bottom and right. And that means that if I have a horizontal wall, it's going to start them from the right of the wall. So on this wall right here, it's going to start the first stud here and then lay them out 16 inches on center as it moves over. From bottom means for any vertical walls, it's going to start at the bottom of the wall that's closest to the bottom of the screen and lay them out 16 inches on center as it moves up. If you want to change any of those options, you just double click on it, the little arrow will appear, and you can adjust that. Maybe you wanted it bottom and left, or top and right. The last two options are from start of wall and end of wall. So where you started drawing the wall, it's going to lay out the 16 inches on center, or where you stop them. For most of you, that amount of detail probably is too much in detail. You're not going to look that closely at the studs. But again, for the manufactured housing industry, that's important. They want to see where those studs are laid out and where they're started from. So that's an important setting for them. Okay, so I'm going to cancel right out of here so we can see that walls on the ground floor, those are the framing options. We know it's using a 2x6 stud for the exterior walls. I'm going to pop this into a 3D view, and let's take a look at the framing. So I'm going to go up to the View pull-down menu, select Framing, and say display the framing. And then it'll erase everything else off but my framing. From there, I can look at the framing, so I can see the 16 inches on center studs, double top plate, single bottom plate. I can see my headers over the different openings. But what if I know that there's a particular wall that I don't want to follow this rule? There has to be something different. Maybe one wall needs blocking. Maybe these 3 walls out the back need a pressure-treated bottom plate. Maybe there's a load coming directly down on this window and I need to beef up the header over top of that window. How can I individually change these and not follow that general framing rule that we set for the entire model? If I go back up to the View pull-down menu, I can select Framing Mode On, Off. When I do that, you'll notice that colors are applied to the walls. Our load-bearing walls become that golden orange color. The non-load-bearing walls are green. Openings become a rose color, and corners are blue, so you can easily identify them. So if there's one wall you need to change, you just left-click to select it, and it will highlight along the edges green. If you need more than one wall changed, you can hold down the Shift key and select multiple walls. So just holding down the Shift key will allow you to select multiple walls at a time as you click on them. So I've selected these 2 walls. I want their framing to be a little bit different. So with those 2 walls selected, I right-click and look at their properties. So right now it's telling me that I can flip the framing side if I wanted to flip them. So if there was an offset that I was using, I could flip that. Or when I'm looking at wall panels, which we'll look at later, I can flip the panel side. That's the first option there. But underneath that it says, for the infill, refer to the location, meaning go up to the settings, building locations options that I set, and use those to frame this wall. If I don't want that, then I can set it to use a custom infill configuration for these 2 walls. Select one that's a little bit different than what I set in my location. So I'm going to select a custom configuration by picking on that button. Brings me into that same dialog box that we were in before, looking at all of our different configurations. So in here, that's when I can choose maybe my new infill that I had set. I select it, I click OK, and now it's going to be using it. The framing rule, meaning am I starting bottom right? Do I want to refer to the location or do I want to start something else? And the span table for this particular wall. Do I want to select a different span table altogether so it maybe puts larger headers in this opening? I could then, again, use a custom span table here. But for these 2 walls, just changing the infill will be OK. So I click OK. And instantly you can see that they're framed with my new configuration. Now what about this opening right here that's got that point load coming right down on it? I can select an opening as well by left-clicking on the rose-colored portion around that opening. It will highlight that particular framed portion of the wall. And then I can right-click and look at the properties and tell it that I need the head, sill, and jamb to be a little bit different. So here you can see that, again, it's referring to the infill. How did I want to set it in the building locations? That's how I want you to frame it. Or I want to use a custom head sill configuration. When I select the configuration, it again brings me back to that part of our catalog where we were looking at before at the different head sill jambs, and I can select one. So I'll choose this 9.5 PSL header. And then I simply click OK and OK, and now you can see it's being framed with that PSL header instead. If I click on a corner and right-click and look at their properties, we can see how it frames corners. When it's framing a corner, there's certain rules and ways that it learns as you frame. So you can see that the default way that it's going to frame corners is a 3-stud energy corner outside. And you get a little visual here off to the right. And if it's hard to determine what it's looking at there in 3D, you can also do that as a rendered outline, so you can see the individual studs going through and get a better view of them. Or I can right-click and say, view that as 2D so I can see the studs that it's laying out in that corner. That might be a little better for some people to visualize. So anytime you see a preview dialog box like this, you can right-click and view it as a different view to help you understand what you're looking at. If I didn't want the default 3-stud energy corner outside, I could say I wanted to, again, use a custom configuration for those corners. Do I want a 2x4 at a 2x6 left, a 2x4 at a 2x6 right? Do I want 4-stud corner? These are all different options. So I'm going to edit the 4-stud corner just to show you the settings that are behind it. And in our little preview here, so it's a little more obvious, I'm going to right-click and view it as 2D so we can see what it means when it's wall A and wall B. You can see them labeled here in the diagram. So when I'm looking at the wall core, when it's looking at wall A relative to wall B, it's going to extend it to the leading wall, and the treatment is going to be square, or it could be flush. I could also have an offset there, and I could also flip the end if I needed to. The end stud you see there is just one end stud, where in wall B, you can see that it's got the 4-stud corner there. So wall A is my leading stud, and wall B is my trailing stud. When I'm looking at the very top plate, wall A, and maybe I'll illustrate this better in a 3D view, and I'll do a rendered outline. Wall A is my trailing end, so wall A going to wall B is the trailing end is at wall B. So see how that extends itself all the way, and B is cut in, and it's B is leading off of wall A. So depending on where you want to extend your top plates, you can even be that particular as well. When you're setting these up, and the software is learning how you want to frame your corners, it can do that by the bottom options here. So it's saying any wall that's basically the same match, 2 walls coming together, just frame them this way. Or a moderate match means when the 2 walls come together and they're the same shape and angle, then frame them this way. And there's also an exact match, so only frame the wall this way when it's this exact angle, shape, and orientation. So if you frame walls differently depending on the angle of the wall and how they're meeting, or the shape of the wall, then you can set up different matches here. But for this particular one, we said basically match it every corner, give us that 4-stud corner so that it'll frame everything that way. Okay, I'm just going to cancel out of here. So that is our corner configurations. How to frame a wall individually and an opening individually. To get back out of that framing mode, I go up to View, Framing Mode On Off, and it turns itself off. To view the framing now with our updated framing, I could go back to View, Framing, Display the Framing, and we get a clearer picture of the framing that I applied. View, Framing, Display all but the framing. I'm going to put that back into a 2D view. Next up on talking about framing, I'm going to use our structural floor tool to put framing in this house. The structural floor tool, again, is only available in Building Essentials and Construction Suite. This particular tool will allow you to lay out the joists, the rim joist, the band joist, the subfloor, and the sill plate, and the subfloor all at the same time. If you're not using Building Essentials or Construction Suite, you're using our regular floor tool that has the floor joist associated to it and only a finished material on top of that. It doesn't have the comprehensiveness, but you can get floor joists from there. So I'm going to do the structural floor by perimeter. You could also do it by each individual room or picking points to define where you want those joists to start and stop. I'm going to use it by perimeter, and then I'm going to show you how that can be adjusted. In the catalog panel to the right now, it'll display the default options that we set up for you for the structural floor. So we set up a structural floor that's a 2x10 floor joist system with 3/4 inch OSB. We also set one up that's using 2x12 joists with a 3/4 inch OSB. And then we also set up a TGI system for you as well. I'm going to double click on the 2x10 floor system so we can take a look at it to begin with. So the 2x10 floor system that's in here right now, it's set up so that the joist directions is 0 degrees. So for those of you who aren't familiar with the degrees in the software, anything going left to right is 0 degrees. If it's at the top of the screen, it's going to be 90 degrees. And then there's our 180 and our 270 at the bottom. So when it has an orientation of 0 degrees, that means it's going to lay out our joist going in this direction. If that was set to 90 degrees, then it would set it up going top to bottom on our screen. I'm going to change our option here to be 90 degrees. The joist spacing, there'll be every 16 inches on center. And then we have joist at bearing. We have stagger and we have hold back. So that means that as our joists come up to a beam that might be in our drawing, they're going to stagger by 1 foot. So it means it's going to bring the joist up to that beam, overlap it by 1 foot. And the next joist that starts is going to stagger down here and do this, so that they're all staggering and going opposite directions. And that distance from the beam itself, that's our 1 foot. Okay, so if you wanted them to overlap by 2 feet or only 6 inches, whatever you need, you can adjust this value by typing on it. If you wanted them to just meet at the beam and stop and hold back, you could do that. So if you were using joist hangers, you would use the hold back option. Next in our list, we have sheathing. And this is where I can specify the material that I'm going to be using for the floor sheathing. You can say include, yes, and then here when I select the sheathing, see that little button that appears? That takes you back to the catalog to select whatever style of sheathing that you want. Again, in any of these dialog boxes, if you don't see what you want, you can right-click and create a new one and describe that new floor sheathing material, floor joist material, whatever you need. The information below that is just quantity information, so when it does do a material list, that it's going to put it in the right part of the list for you. Next, we have joists. The joists are going to be 2x10s, and that's an actual member from our catalog. We looked at the purchased items lengths of the 2x6. It'll be the same for the 2x10. They'll have predefined length. Purchase the 2x10s in. If I wanted to rotate them, I'm just going to pop this up here. So I wanted them for whatever reason to be on the flat, I can do that. And again, our quantity information. When I'm positioning them, I want them to be all aligned at the very top of the member. Our sill plate. If this is going to be on maybe a ground floor location, I want to include the sill plate around the foundation, I can have it here. If I don't want it, I can delete it out. So if this is going to be on a second floor location, I can delete out that sill plate. But for my ground floor location, if I wanted to include it, again, I can go out to my catalog and choose a specific member that I want. Here I'm using a 2x6 treated sill plate. I'm putting it on the flat, so I've rotated it 90 degrees, and it's going to be part of my foundation construction phase, and I'm labeling it as a sill plate. My band joists running perpendicular to my joists are again going to be 2x10s, and I'm going to label them as a rim joist. My rim joists are again 2x10s running parallel to my floor joists, and they'll be labeled as rim joists as well. If I later cut a hole in the floor, maybe for a stairwell, it's wanting to know what to frame around the opening with, and it's going to use 2x10s. That's all the information that's included with this floor. So it's putting a lot of members in all at the same time to save you time of inserting them individually. So I'm going to click OK here to select the changes that I made to that 2x10 floor. And then all I do is move it into my drawing screen area, and I left click once. I'm going to go down to my view filter and tell it that I want it to turn on the structural floor framing so I can see it. And click OK. There's my floor framing. Now, what if I wanted to make some changes to that? One, I don't want it in my garage area. I want to eliminate it from there. Two, I want to show that there's a bearing line coming in here and the floor joists are actually going to overlap at this point. How do I change that? First, you have to select the structural floor itself to be able to adjust it. Because the structural floor lies along the same line as our wall lines and perhaps ceiling lines and the subfloor lines, you have to scroll select it. So I'm going to select the wall along this edge, and then holding down my Shift key, I'm going to be scrolling with my scroll wheel on my mouse until I see this. Once I see those red arrows, I know I've selected the entire structural floor system. I also know that I've selected the entire structural floor system by looking down at the bottom of my screen in the prompt area. The prompt area is telling me that I've got one object selected. It's the primary object of the 2x10 floor system with 3/4 inch OSB structural floor system. I know I have that selected. With it selected, I can do a number of things. One, these red arrows that you see are pointing to all the individual walls that they're bearing on. If I want to change any of that, there's also a blue grip that's at the end of that arrow. So if I put my cursor to the end of that arrow on that blue grip, notice my cursor change. It goes into the move cursor. So by holding down my left mouse button, I can drag down the structural floor and tell it that I want it to start here. So a very quick way of applying the whole floor to the entire model and then just dragging it out of the pieces that I don't need. So I didn't have to go through and pick all the points around here. I put it in the whole space and then dragged it out of one area. A lot quicker than picking points and a lot more accurate, I would say, as well. Now I also want to show it that I'm going to be later on putting a beam through here, so that's going to be a bearing line. So I want those joists to cut themselves at that line and overlap. So I'm going to right-click with the structural floor still selected, and when I right-click and see the options, I can see structural floor. There I can insert a bearing line. Insert a line to show it where I'm going to have a beam so it knows to cut the joist at that point. So I'll select Insert a Bearing Line. I left-click once where that beam is going to start, and I left-click where it's going to stop. Instantly, it cuts the joist in that area and overlaps them for me. So now I have two different joists in that area and overlapping where I want them to. Okay, so that's using our structural floor tool. If I put in a ceiling, and I'm just going to put a ceiling by room so we can distinguish it from the floor framing as it goes through. In our catalog of ceiling choices, we have framed ceilings. So I'm going to choose the 2x6 framed half-inch drywall ceiling and left-click in this particular room. And then right-click and tell it I'm finished. The only way that I know that I have the ceiling is that little red dashed line that's going to go around the perimeter of the room itself. If I put this in a 2D designer's view down the bottom of the screen, the little 2D that's green, I can also see that I have the ceiling in there as well. But going back to 2D blueprint, I'm going to select the ceiling by selecting on that red dashed line. I'm going to right-click and look at the properties of the ceiling so you can see how you can adjust the framing for a ceiling. When you're in the ceilings dialog box, you'll see a button at the bottom called Specify Framing. And in here you have a number of selections to make about how you want to frame that ceiling. Do I want to include it in the framing? Yes, I absolutely do. What member do I want to use? Well, I want to use a 2x6. And yes, that does go right back to our catalog and choosing an actual member to frame it with. And it'll look at those purchase member lengths and get you the right lengths for it as well. It'll label itself as a ceiling joist in the ceiling construction phase, and it's going to space them 16 inches apart. The direction is 90 degrees, so it's going to be up and down on my screen. I'm going to change that to 0 so we can distinguish it from the floor framing when we look at it. Is there a rim joist around the perimeter of our ceiling? Yes, and it's also a 2x6. If I put an opening in the ceiling, perhaps I have an attic access that I want to put in, what is it going to be framed with? Again, you can see here that it's 2 by 6. All I have to do then is click OK, and that's how it's going to frame it. If I go to my view filter, look at ceilings, turn off the surface, turn on the framing, click OK, now I can see my ceiling joist framing. The difference between the structural floor framing and our ceiling framing is that when you use the structural floor tool, all of the framing members are individual members. You can see how I can pick up and grab each individual floor joist. I can move them around, I can duplicate them, double them up where I need to, and move them right off there. With the ceiling framing, it comes as a package. So that framing that's in there are all grouped together. So if I expand the ceiling or make it smaller, the framing is going to reframe itself and regenerate itself. You can't move the individual pieces. You can move them if you went to insert the members and told it that I wanted to convert the framing to members. That means it's going to convert the framing that's part of my ceiling to individual members. So then they'll be separated from the ceiling surface. They can't be placed back in once you convert them. Once it's converted, they're all individual pieces. But then you can move them, double them up as you need to. But just know as well, if you do cut a hole in the ceiling later, because it's not a framing package anymore, they're individual members, it doesn't know how to put that header around it. Okay? The last framing that I want to look at before we look at your questions today is the roof framing. So I'm going to put in a roof by perimeter, and I'm going to look at our 612 hip roof with shingles. When I'm looking here, there's two things you need to make sure are set to make sure that it frames with rafters. First is under the Support and Details tab. Make sure the support type is set to rafter, not truss. If it's set to truss, you won't see any rafters appear. You need it to set to rafters. It currently doesn't show any trusses, but you can, if you have Construction Suite, export it out to a software like MyTech to be able to create the trusses. So I want to do the rafter framing, so I'm going to say my support type is rafter, and then I go to the Basic tab. Down at the bottom of this dialog box, where we put all of the Specify Framing buttons, if you've been looking at these dialog box, the ceiling was down there, the floor was down there, they're all right at the bottom. Specify the framing, and then I have all of these various framing parameters to set for my roof. What do I want to use for my rafter? I want a 2 by 8 from the catalog. I want to space them 16 inches apart. What do I want for a header if there's an opening? I want a 2 by 8, and I want you to still call it a rafter. What do I want for my fascia boards? Well, I want those to be 2 by 6s, and I want you to call those subfascia. What about my ridge? I want it to be a 2 by 10, and I want it to be enabled as a ridge beam. What about my hip boards? They're 2 by 10s as well, and my valley boards, but my gable boards are 2 by 6s. So you can come in here and switch those members around to how you're going to hand frame that roof using rafters. So it's using the member sizes that you would use for all of those various pieces. Just going to click OK and OK. Choose that 6 and 12 roof, left click inside the house, and it'll put the roof on. And if I put this into a 3D view, we can go to View, Framing, Display the Framing, and we'll be able to see our floor framing, our wall framing, our roof framing, and if I tilt this around just right, you'll be able to see that ceiling framing under there too, in that one room at the back. You can see those going through there. I'll just zoom in, and you can see those ceiling joists going through. A lot covered today in today's class. I hope you've been asking questions, and I just want to review quickly everything that we talked about today. When we draw walls, each one of those walls have properties behind them to tell you that I'm a framed wall. Use a 2 by 6, use a 2 by 4, use this particular member when you're framing this wall. How it gets the layout of that framing is found under the Building Locations dialog box. The very last column of information there is framing options, and each location can be framed differently than other locations they can have their own unique framing properties. By double-clicking on any one of the options that you see in here, will take you into the catalog so you can select the framing choice that best suits your needs. And again, if you don't find one in there, right-click and create your own to set up your special framing parameters. When you're framing and you want to make choices that are different from the choices that we originally see, like a header opening or how it's going to frame one individual wall, go up and put it into framing mode on-off. So that allows you to pick on one particular wall or a couple, pick on one opening or the corners to frame those individually how you want them to be framed. When you're framing your floor, I highly recommend using the structural floor tool. It allows you to place the floor joist, the subfloor, the sill plate, and the sheathing in at the same time. If you're using Pro Architect, you'll be using just the floor tool. And the floor tool, if I look at it, can have some basic framed options to it as well. Basically just letting you lay out the 2x10s or your floor joist and your rim joist in a header. They won't be individual members that can be manipulated. You won't have the option like we did to insert that bearing line. When you're putting in the ceiling can have framing properties to it as well, and they will be grouped together. So when I'm telling it that I want 2x6 framed, all of the ceiling joists are going to be one group of information. If I want to separate them out, then I have to go up to Insert, Members, convert the framing of my ceiling to individual members. They can't be grouped back together, so that should be a final option if you do want to manipulate them. The last option that we looked at is the roof. The roof itself can have individual framing elements for the ridge, for the hip boards, the valley boards, the fascia boards, and you can specify those all in the properties of the roof itself. One thing to keep in mind about the framing of a roof, make sure under the Support and Details tab, if you want it framing with rafters, that it has to be set here to rafters. If it's set to truss, it will be blank. Under the Basic tab, also make sure that you have information set here about framing, and make sure Include in Framing is set to Yes for each one of those. With both of those set, you'll be able to frame your roof. What I'd like to do now is answer any individual questions that you might have about using the framing in Envisioneer. So in your GoToMeeting panel to the right of your screen, you can type in any questions that you might have, and I'll be able to answer those for you. Let me go and see if we have any questions to begin, and we do. Why was the truss option taken out from Envisioneer when it was in the AP Design Suite? AP Design, for those of you that aren't familiar with that product, it was our product from, I'm going to say probably 16 years ago now that, that we stopped selling it. AP Design was based on lines, not objects. So when you're drawing in that software, it was in AutoCAD with lines. So to be able to draw the trusses as a 2D diagram was much easier than a 3D element. And that's why we haven't included it thus far in Envisioneer. But if there's more call for it and people want to be able to design their own trusses, you can do so. Most of the people I talk to say, I don't design my own trusses, I get somebody else to do that for me. And they get drawings associated with that. But that's something, if there's a call for it, we could bring back. Any other questions from anyone else in our audience? You're a quiet group today, so that means either I have bored you to tears, you understand everything thoroughly, or I went completely over your head. So I'm hoping that everybody understands it thoroughly and is going to be ready to use their framing and all of their different models. So it's going to count those materials for you, and you're going to get accurate framing diagrams from it as well. I also want to remind you that following today's presentation, we will be emailing you out a booklet about framing, so you can review all of the options that I went over and read about them. So if you do learn better by reading and looking at the different dialog boxes, that'll be following the presentation. We also do record the presentations, so this will be available up on our YouTube channel. And it'll be a link in the email that I send out as well, so that you can find it there. It just takes basically a day to be able to convert it from the GoToMeeting format into something that YouTube will accept. So give me about a day to be able to process that, and then it'll be available for you. But there are past presentations up in our channel that you can watch. Okay, that seems to be all of our questions, other than trusses would be good, so we'll see what we can do for you. I'll leave the chat panel open for one more minute. So if someone is typing in a question, I'll be able to get it answered for them. But if there aren't any questions in the next minute, we'll end off the presentation. I'll send you the booklet so that you can read up about framing, and then you'll be able to watch the video once it's available as well. A question came up, how do I insert a single member, for example, the beam itself? That's found under our members command. And we do have another webinar called Lumber Beams and Columns, and that one really goes into this one, into members themselves in great detail. So if you do go up to our YouTube channel, you'll be able to find that one in our past presentations of different webinars. But basically, just coming in here to members and advanced members allows you to insert what you could call a beam, and it could be any member itself that you could insert and have it lie where you need it to. Great question. Okay, that seems to be all of our questions for today's class. Thank you so much for joining me and taking time out of your busy schedules to be in here for this class. I hope you enjoyed the presentation, and I hope to see you again next week. Thanks, everybody. Bye-bye.